Hello everyone, today we will present on topics nuclear fusion, the quest for clean energy and its potential impact. So this is an example of nuclear fusion. The focus on our presentation is to explore the principle of nuclear fusion, which has the potential to be a clean and abundant energy source. Besides, we will discuss different approaches to achieving controlled fusion. Furthermore, we will analyze the technological challenge and recent advancement in fusion research. Lastly, we will evaluate the impacts of fusion energy if it becomes commercially viable.
Hi, my name is Effendi, and I'll be talking about the principle of nuclear fusion and nuclear fission. To start off, nuclear fusion is a nuclear reaction in which small and light nuclei fuse to form a heavier nucleus while releasing a large amount of energy. While nuclear fission is the opposite, which is it's also a nuclear reaction where a heavy nucleus will split into two or more lighter nuclei, which also release a large amount of energy. And how does it differ? Nuclear fission and nuclear fusion. Okay, from the first aspect is the energy output. Nuclear fusion produces more energy per reaction compared to nuclear fission. And for the byproduct aspect, nuclear fusion produces minimal radioactive waste, which we can consider a clean energy source, while nuclear fission generates a radioactive waste that requires a long-term management. And for the application, nuclear fusion are used in hydrogen bombs, but they are still at an experimental stages for energy production. While nuclear fission are used in nuclear power plants to generate electricity in nuclear weapons such as atomic bombs. And lastly, the conditions for nuclear fusion, it requires an extreme amount of temperature at 1,000,000 degrees Celsius, while nuclear fission requires fewer extreme conditions and it's more easily controlled compared to nuclear fusion. That's all from me.
The question is, what are the different approaches to achieving controlled nuclear fission and what are the technology's challenges? So the first one is magnetic confinement fusion, MCF, used from magnetic field to confine a hot plasma of hydrogen isotope like deuterium in stable configuration. The main challenges is plasma stability and high temperature. So the second one is I found magnetized target fusion, MTF, combine element of MCF and ICF by compressing a magnetically confined plasma. The main challenges is linear design and energy coupling. So the third one is I found initial confinement fusion, ICF. ICF relies on compressing small fuel pellets of deuterium and tritium using intense energy bursts from laser or particle beams. The main challenges is uniform compression and repetition rate. The last one is in advanced concept, we have direct fusion drive using fusion to direct generate thrust for spacecraft. The main challenges is requires ultra high plasma temperature.
Next, I will talk about the advancement of fusion energy. In a groundbreaking leap for energy science, fusion research is delivering milestones that bring future closer than ever. First, in December 2022, NIF broke the barrier by producing 3.15 megajoule of fusion energy, surpassing the initial threshold with a remarkable efficiency. Next, in May 2024, innovation of 3D field optimization using machine learning stabilized Tomahawk plasma without sacrificing performance, achieving unparalleled results by protecting machine component. And finally, in February 2024, European research set a new world record generating 69 megajoule of sustainable fusion energy, another giant leap toward a sustainable future. For the outlooks, private companies like Commonwealth Fusion System are pushing boundaries, aiming the demonstration of scalable fusion by 2025 and deploy the first commercial ARC power plant by early 2030. And finally, for the outlook, with the world's first commercial fusion power plant about to begin operation, fusion energy is no longer a dream. It's becoming reality. The journey continues toward a clean, limitless energy in the future is not far from us.
In this part, we will explore how the fusion energy will give a positive potential impact on the environment, economy, and society. So, in terms of environment, there will be no global warming. Why? Because the fusion energy has the potential to reduce global carbon emissions since it is one of the most environmentally friendly sources. It doesn't produce any carbon dioxide or other harmful atmospheric emission that can give into a greenhouse effect. And other than that, to operate a fusion energy, that will need a minimal length of use because the nuclear energy produce more electricity compared to another renewable energy sources. For example, typical 100,000 megawatt nuclear facility in the United States needs a little more than 1 square mile to operate, compared to solar energy that will need a 3 million solar panels to produce the same amount of power.
So I will talk about another potential impact of fusion energy. First impact on the society. The first point is that the fusion energy is harmless to human health. It is because during the process to generate energy, it doesn't produce any long-life radioactive nuclear waste, but instead it produces helium or tritium that is harmless to human health. Other than that, it can create jobs. It is because fusion energy is something new for this generation. So when we decide to use the fusion energy, it can create jobs for many people. For example, like 300 to 500 people. Lastly, in the economic aspect, it has low operating costs because the source of fuel are hydrogen and lithium that can be found in water. Therefore, it will lead to cheaper source fuels.